Good morning. I just thought I would make this little video in case what Sal Khan is explaining you're not getting and you just missed the sound of my voice. So what we're going to be doing is we're going to be talking about series today. And the first thing with series is a series is basically the sum of a sequence. So, So when we consider the sum, which is 1 plus 3 plus 5 plus ... what we're really doing is we're adding the odd integers, positive odd integers. So we would add 1, that's 1. 1 plus 3, well, when I add 1 plus 3, the 1 plus 3 is what gives me 4. Then when I add 1 plus 3 plus 5, oops, sorry about that, 1 plus 3 plus 5, that gives me 9. And then 1 plus 3 plus 5 plus 7, so 9 plus 7 would give me 16. And then the next odd number would be 9. So when I add 9, that would give me 25. So when I look at this, I'm asking myself, what's the sum for this formula? Well, what did I do here? Well, this is term number 1. So when I'm looking at the sum, I just add the first term, which was 1. When I add the second term, I get 4. When I add the first 3 terms, I get 9. When I add the first 4 terms, I get 7. When I add the first 5 terms, I get 25. What's the relationship between the term number and the sum? Okay, so it is the term number squared, right? So our formula for that would just look like S sub n, so the sum would equal n squared. So if I wanted to find the first 10 terms of the sequence, I would just put n equals 10, and 10 squared would be 100. So what we're going to be looking at today is, first off, this isn't your homework. Your homework is online now, so you're going to do what's on It's Learning. We're going to learn formulas to find the sum of any arithmetic series, and we're going to find formulas to find the sums and solve problems with geometric series. So that's our goal, is we're going to learn some formulas. So an arithmetic series, first off, what is a series? A series is a sum of particular number of terms of a sequence, regardless. An arithmetic series is when you add the sum of particular numbers of an arithmetic sequence. So just what we just did, that was an arithmetic series, because each time we did it, we were adding 2, so it was an arithmetic sequence, and we added those terms, that was an arithmetic series. So if we have the arithmetic sequence 5, 9, 13, what's our first term? Good, first term is 5. What's our difference? 4. So that's something that you want to make sure that you're into. So I know that A1 is 5, and I know my difference is 4. So that's something I want to make sure I'm aware of as we're going forward. So when I look at this, if I find the arithmetic series, so of the first 4, I would need to find the first 4 numbers. 5 plus 9 is 14, plus 13 is 27, plus 17 is 44. So that tells me the sum of that series would be 44. If I were told, so let's pause here for just a second. If I know that this is 5 and this is 4 for the difference, how can I write an explicit formula for that? Well, we know that our explicit formula says a sub n equals a sub 1 plus d times n minus 1, right? So since we know that, we can substitute in our numbers. So that means that for this particular sequence, so we have our sequence, which is a sub n. Our first term is 5. Our difference is 4 times n minus 1. And if we simplify that, so that's 5 plus 4n minus 4. So that's 1 plus 4n. So what we actually did here when we added these first 4 terms is we put 1 in, that gave us 5. We put 2 in, that gave us 9. We put 3 in, that gave us 13. We put 4 in, that gave us 16. So that's how we found our sum, by using this formula to put in to get each of those terms. Now, what if you're young Carl Gauss or young Einstein or young Brady Waugh, and you're doing so good in math that your teacher says, hey, I need you to do something for me while everybody catches up. So you decide, she says, I want you to add the first 100 counting numbers. So I want you to find the sum of 1 to 100. And she walks away thinking, I taught him a thing or two. And she gets to the front of the class, because obviously she puts the smart kids in the back. So she gets to the front of the class and she says to the front of the class, all right, so now let's go on. And next thing you know, here comes the boy up to the front, or the girl, but in my examples, everybody was a boy. Not that they have to be. Bree, you could, Matt Kenzie, I mean, I don't want to upset anybody. Mia, any of you could have been the smart two in the class. Jocelyn, Gabby, don't be upset. Find the sum of the first 100 counting numbers. So what he did is before she could start talking on the next topic, he knew the answer. She's like, how did you do that? I wanted you to add the first 100 numbers. And he said, okay, well, that's what I did. I added 1 plus 2 plus 3 plus 4 plus 5 plus, and I wrote them all down. And what I noticed was, when I add 1 and 100, when I add 1 and 100, that's 101. When I add 2 and 99, that's 101. When I add 3 and 98, that's 101. When I add 4 and 97, that's 101. So what I noticed was that every time I did this, I was getting groups that were 101. So what happens? Well, what happens is, how many groups of these do I have? Well, there were 50 groups. All right? So I was adding the first 100 numbers, so I made them into pairs, and I took the first number plus the last number. So this was my first term. This was my nth term, or my last term. And there were 50 groups. So I just did 50 times 101. So the sum is 50 times 101, or 50 times 50. Now, in terms of the numbers I did, you told me to add 100 numbers. So that meant that n was 100. Right? I knew my first term was 1. I knew my last term was 100. So I really just did n divided by 2 times the sum of those two terms. Oops. 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 And that's one of our formulas. So when we have this, we have two ways we can calculate the formulas. That's the first one that we just did. That's the one that Gauss came up with. I think it was Gauss when he was given that problem as a child. The other formulas are these. Now, what are the advantages of both formulas? Well, this formula, you have to know the first and you have to know the last term. If you don't know the first term or the last term, you can't use that formula. Here, you have to know the first term and you have to know the difference. So as long as you know the difference, you're set. So you can see that depending on what information you have, depends on which formula you want to use. So if you know the first and last terms, then this is the easiest one to use. But most of the time, you're not going to know the first and last terms. So this one right here would probably be the formula that you would want to use. I lost my pen. Sorry, guys. Okay? So the next question says to find the first 10 positive integer multiples of 12s. So when I'm looking at this, I'm finding the first 10 positive integer multiples of 12. So do I know the first term? Well, the first term is 12. Do I know the last term? Well, the last term is 10 times 12, which is 120. So I would probably use that formula because the first term is 10 times, the first term is 12. So since we're doing the first 10 positive integers of 12, I know A1 is 12, and I know AN is 10 times 12, because it says to find the sum of the first integer multiples of 12. So that's 12 times 1, 12 times 2, 12 times 3, 12 times 4, so forth and so on. And so that gives me a sum of 660. Now, if the sequence had been a little different, oh no, you did it, Finney. You did it. You put that big E there. What does that big E mean, Finney? The big E means we're doing a summation. So what this actually means is that we're going to put 1 in. So we would do 7 times 1 minus 3 plus. So that's our first thing. Then we look at the top. It stops at 8. So then we do 2. 7 times 2 minus 3. We look at the top. It says 8. So then we do 3. So we have 7 times 3 minus 3. And we do this all the way till we have 7 times 8 minus 3. And that's what that summation means. You're going to add the first 8 terms. So what this is saying is the first 8, because it starts with 1 and ends at 8. So do we know our first term? Well, our first term is 7 times 1, which is 7, minus 3. So our first term is 4. Do we know our difference? Yeah, we know our difference. This right here is our difference. So our difference is 7. So since we know A1 and D, we can use that to plug into a formula. Or we could do that. Now what I was suggesting over here is that we do 8 divided by 2 times 4 minus 7 times n minus 1. Because isn't that our other formula? Oh, it's plus. Okay, so when I do this, my n is 8. So 8 minus 1 is 7. 7 times 7 is 49. 8 Okay, so my formula was wrong. So this is 2 times the first term. So 2 times the first term is 8 plus 49. 8 plus 49 is 57. And 57 times 4 is going to give us 228. So either way you do that, it's going to work. Let me just erase this so you can see that other formula. Sorry about that, guys. So you could have done it either way. Okay? But this is where you get your difference. I do not like to use it. All right. So now what we're asking you to do is pause the video. Pause the video right here and answer these questions. Now, if you're stuck on these, this is something we can talk about in one of our help sessions. Right now our help sessions are scheduled for Thursday at 2 o'clock and Friday at 2 o'clock. I put them late in the week simply because not everybody will have time on Monday and Tuesday, or Tuesday and Wednesday, to access everything. So I figure by Tuesday, Wednesday you've tried the stuff. Thursday, Friday you're trying to work it out. It's not due till Monday at noon, so bam. So that's why I chose that. Now the next thing we're going to look at are, no, that's it. Next thing we're going to look at is a geometric series. Geometric series is the same thing as an arithmetic series, except it's for a geometric sequence. So the sum of a particular set of numbers of a geometric sequence. So when we're looking at the geometric sequence, we've got 3, 6, 12. What's our first term? Well, our first term is 3. What's our ratio? Well, what are we multiplying by? 3 times what is 6? So 6 divided by 3 is 2. 12 divided by 6 is 2. So our ratio is 2. So that we know. So as we go to add this, we're going to add the first 4 terms. 3 plus 6 is 9. 9 plus 12 is 21. 21 plus 24 is 45. Bam. So what we're looking for here, is there a pattern to find the sum for a geometric sequence, or for a sum of a geometric sequence, which would be a geometric series? So if I add 1 plus 3 plus 9, okay, so my first term is 1. What's my ratio? 3. My first term is 1. What's my ratio? 4. My first term is 4. My ratio is 3. My first term is 14, and my ratio is 5. My first term is 20, and my ratio is 3/4 or 0.75. So how can I look at what this sum might be? Well, if I add this, 1 plus 3 is 4, 4 plus 9 is 13. 1 plus 4 is 5, 5 plus 16 is 21. Sorry. 4 plus 12 is 16. 16 and 36 is 52. So these are like for the first 3 terms. Is there a connection? Well, let's look. So 3 to the third is 27. 27 minus 1 is 26. 26 divided by 2 is 13. Hey, that worked. Let's try the next one. 4 to the third is 64. 64 minus 1 is 63. 63 divided by 3 is 21. Why did we divide by 2 here and 3 here? So 4 times n to the third minus 1. So n to the third is 27 minus 1 is 13. 13 times 4 is 52. 52, I'm sorry, 27 minus 1 is 26. 26 times 4 is 104. Divided by 2 is 52. And now we're dividing by 2 again. Okay. What are we going to divide by in the next one? Let's see if you're right. Were you right? So this time we're going to do 5 to the third minus 1 times 14, and then divide that by 4, and we get 434. That works. What are we going to divide by in the next one? Yeah. So take a look here. What do you notice? Well, what I notice is this, the thing with the exponent. Every time, that's our ratio. So we always have r to the n minus 1. Notice that. Then there's no number in front here. No number in front here, but here there's a 4. Here there's a 14. Here there's a 20. Which means that that's probably the first number in the sequence, which means that this was probably a 1. And this was probably a 1. Because 1 times that doesn't change anything. So that tells me that this is G sub n. And what are we dividing by? Well, we're dividing by r minus 1. So r minus 1. Now check it out down at the last one, because that's 0.75 minus 1, so that's why we got a negative. So the order matters. So this is how we find our sum for a geometric series. So that's our formula. So for a finite geometric series, these are your formulas. All right, so those are our two formulas. G1 is the first term, R is the ratio, and N is your number of terms. So if we want to find the sum of the first terms of this geometric sequence, we need to know the first term. So our G1 is 8. What's our ratio? Well, remember to find the ratio, you take the second divided by the first. So we're going to have 12 divided by 8, which is 1.5. And we're finding the first 10 terms. So you plug it in. And then we have it in summation notation, which again just means you need to know the first term, we need to know the ratio, and you need to know how many terms they are. So our first term is 12. Our ratio is 0.7. And the number of terms is 8. So these are some you can practice. Now, we're going to pause right there and